In this video, we'll talk about solving one-step equations. So I think the best way to go through these is to just talk about an example. There are some generic properties that we'll kind of discuss while we go through these examples. So say I wanted to solve this equation, x plus 4 equals 7. And I think it's pretty easy to see that it's going to be 3. 3 plus 4 makes 7. Now the reason we do this is that we're going to talk about other cases where we may not be able to figure it out intuitively, so we'll need a system in order to do so. So the idea is, if we are adding something to x, we can undo that addition, and we can undo that with subtraction. Now, this is an equal sign. What I do to one side of the equation, I have to do the other to maintain that equality. If I subtract 4 from this side, but not this side, this equal sign no longer applies. So, if we're looking at this, I have x plus 4 equals 7. If I subtract 4 from both sides, I can do that so long as I'm doing the same thing. This should still be equal. So the plus 4 and the minus 4 will cancel, leaving me just x on the left side of the equation, and x equals 3, as we kind of predicted in the beginning. But this just gives us a method in order to do so, which when we talk about two-step and multi-step equations, going to be very, very important to be able to do this and keep the order as we need it to be. But for now, x equals 3 is our solution. Very similarly, if we're talking about a subtraction equation, well, it would make sense that if I could subtract something from both sides of the equation, I can also add for the same logic. So if I wanted to undo this subtraction to figure out what t is, I could just add 12 to both sides of the equation. So long as I do it to both sides, I maintain the equality. So t is going to equal, in this case, 20. 8 plus 12 makes 20, and there's my solution. So long as I add 12 to both sides, everything is fine. Now let's talk multiplication. If we have 5 times z equals 60, again, it would make sense that I could divide both sides by 5, and so long as I do it to both, I maintain the equality. If I divide both of these by 5, they should still be the same value. Now, the benefit of this is this turns into a 1z, which is what we want. So z is going to equal 60 divided by 5, which is 12. And in this case, that is our solution. Now, similarly for division, if we're looking at this, we have k divided by 7 equals 28. Well, to undo the division, we can multiply. And so long as I do it to both sides, I maintain the equality. So I'm multiplying one side by 7, I multiply the other. So k is going to equal 28 times 7, which is 196. And that would be the solution to our equation.